Aloha and welcome. In this lesson, we're going to be talking about equipment protection. We're going to start talking about the physical device protection. We've got two different methods we're going to talk about. One is air gap, and the other is a USB data blocker. So air gap is simple enough to understand, and it's one of my favorite expressions. But air gap is when you actually put physical air between you and a network. It means that, or you and another device. So let's say you had a computer and you wanted to separate it from the network, you would create this air gap by, having it, inaccessible through the network. So you would have, yeah, you'd essentially have no wired network to it. You'd have no way of it reaching it. So the traditional way of attacking a system, of course, is going to be through wireless or wired networking. But if you have a computer that is offline, that is entirely, separate, you don't have that problem. So, for example, if you have a backup server that you have, you may want to have a backup server that you only connect to the network when it's time to do the backups, and then you disconnect it. That way, if a hacker gets in, they wipe all your systems. They won't also wipe your backup server too. And that's one of the dangers when you're thinking about. So there's two aspects here. One, and this isn't talked about in the book, but I wanted to explain it to you. But one is that when you automate a system, you can also find a way to hack it, and that's not good. So, for example, if you're using a network attached storage to save stuff on, like your backups and everything else, if an attacker gets in, they wipe out your system. They're probably also going to look for your storage devices and try to, mess those up as well. So if you have all your backups, attached to the same system that it's visible, even if it's on the network, if it can see it and it can get to it and it can destroy that, then you essentially have no backups in that sense. So you need to air gap it. You need to separate it somehow, whether that's a system of, plugging in your an external hard disk to do a backup or something like that. But that brings up the other trade-off. The other trade-off is now you don't have an automated process, which is a really so the extent to which you can automate a backup process is good because you don't have to rely on user input and a user's memory, and so you don't have to remember every week, oh, I need to attach this so I can do the backup and then I can undo it. You don't have to remember to do that step every day or every week or whenever it is you're going to do that backup. But if you can automate it, so on the one hand, you've got full automation where you just have all your backups being taken and then sent to, the backup server. The trade-off is that it can be hacked. If you air gap it, fine, you can air gap it and then you can do your backups, but then you have to remember to unattach it. And so you have to do the attachment, then unattach. So you've got a human, in the middle, and that can be a source of error there too. So that's one of the trade-offs that you have in automating things like that. But that's not part of the discussion here. The main thing we're talking about is air gap, and air gap is putting that distance between an important piece of equipment and the network so that nobody can connect to it. Another concept we have is the USB data blocker. So USB devices, whether it's something like a connector, let's say it's something like this. You have your USB-A connector. Let's say you go to an airport and you plug it in. You want to charge up your device. Well, the USB-C has both power and data delivery. So what happens is when you plug this in, you can essentially be hacked. So if they've figured out a way to get into the whatever it is you're attaching to, they can be doing things like installing malware on your system, or they can do things like try to exfiltrate data. So you want to have something on there that blocks your data line. So you can order things through Amazon that are basically going to block that channel. So you've got your power and your data channel. You can effectively put these little adapters onto it that will knock out your they'll knock out your data line, so only power goes through. So that's a really smart thing to carry with you, especially when you're on trips, when you're going to conventions, or when you're in the airport. Always carry a data blocker. It's just a tiny little device about this big that you put it onto the end of your USB, and you have to remember whether it's USB-A or USB-C, whatever it is. just remember to bring your adapter that has the data blocker built in. So anyway, so that's our physical device detection protection there. When we talk about physical network protection, like the physical network around us, we have a couple of options. So let's say we have a computer in a room and it's being served by these cables, just like a Cat5 cable or something like that. Normally, you run it through the plenum, you run it through the ceiling, and you'll drop it down or something like that. Sometimes it comes through the wall. But there's, when it's in the ceiling or something, let's say a hacker gets access to your building and they come in there and they can put what we call a tap. They can put a tap on your cable, and then they can send that signal somewhere else where they can be receiving your data and everything else and be the man in the middle there. So you don't want a situation like that. So there's ways of protecting your cables. So you do a protected cable distribution. So you would have those cables, instead of just running loose or something like that, you would put them inside a metal enclosure that would run along the lengths, and that would provide that the protection that you need to make sure that nobody's able to physically get in and tap into it and splice the wires or anything like that. So we've got protected cable distribution. We also have something called a Faraday cage. Faraday cages are essentially rooms that block out electronic signals, wireless signals. Elevators are great examples of this. So a lot of people, when they get into an elevator, they lose their connection, and that has to do with the different aspects of the enclosure there. But a Faraday cage, it's a mesh enclosure that's specifically designed to block electromagnetic fields like Wi-Fi signals. So you can buy them as well. So if you go on Amazon, you can buy pouches that are made, as Faraday pouches. It's questionable quality on some of these things, but it's always great to test them. So before I went to DEF CON, there's a hacker convention in Las Vegas every year called DEF CON. And DEF CON, it's famous for having people that like to hack systems, do all kinds of wireless mischief. So they recommend that before you go to DEF CON, that you actually go and buy yourself a wireless or a Faraday bag and put your phone inside of it. They recommend you turn off your wireless and your Bluetooth and put your phone. And also, if you think about your credit cards all, probably have those little wireless, marks on them. Take those as well and put them in a Faraday bag, they said. So you'd block all the signals so that nobody's going to be, snooping your devices and your cards. So so a Faraday bag is something that's very helpful in that sense. And they have some that'll even accommodate a laptop. So I got one that would accommodate a large laptop. I just put that inside my bag. One thing to think about with these Faraday bags, or the Faraday bags can break up over time as you bend them and things like that. So the material, it doesn't last forever. So there's a half-life on that. But a Faraday cage is built as like a room or something like that. And that Faraday cage is built in with mesh to keep the signals from going out. So that's very that's supposed to be permanent. So anyway, so that's physical network protection there. We have ideas of secure areas within a building that you can physically secure things. So you have a vault. Vaults are usually large rooms that are very secure. You've seen pictures of bank vaults and things like that, where they have all the tumblers and everything, and you have to, open it a certain way. And these are built into the structure of the building. So these are actually anchored into the structure of the building itself. And it's very hard to add one of these things after the fact. You have smaller, much smaller, more portable versions of these, safes that you can put in a room to secure things like documents or maybe USB drives, removable storage, things like that. So safes can be, really tiny, or they can be, larger. And these, give you a good amount of security, even though they can be removed. They're often very heavy too, so that prevents the easy removal of them. But safe is a smaller, more movable, secure area. And then we talk about cooling, because cooling is also important when you're talking about the physical, safety of things. So when you have server rooms and you have server racks and everything, they have this concept of a hot aisle, cold aisle system. And that's that in order to keep these systems running efficiently and running in a really I guess, a robust way. They'll have the servers in a room lined up so that you have a hot aisle and then a cold aisle, and then you'd essentially, and this is for heat purposes because these servers are generating a lot of heat. And when you go up to your computer and you feel the back end where the fan is, you can feel it pumping out heat there. If you've got a GPU running, you get a lot more heat, from that too. So with servers that are usually, cranking out a lot of heat, you're going to have it where they're putting out their exhaust into the back, and you want that going into a row. And then you're going to have above that, you're going to have the heat that exhausts out. You're going to have it going up into a system, a ventilation system. It's going to pull in all that heat. It's going to sink it into a cooling unit. Then it's going to cool that, and then it's going to pump it out through the floors. And so the cold air is going to come out through the floors and then go back into the system. So it creates this loop, basically a circuit, if you will, of of heat going out, then being cooled, and then pumping out the cool air that's going to be circulated back into the systems. So that's so you need to know that you've got hot aisles and cold aisles with that. So it's alternating hot and cold aisles in a server room to manage the heat and cool the servers. And that's pretty much it for this chapter. To recap, we're talking about equipment protection. We start with physical device protection, air gapping systems using data blockers on cables that we use. We talk about physical network protection, like protected cable distributions to make sure that your physical cables are protected in metal, enclosures. Faraday cages to protect, keep your wireless signals from leaking out or being accessible. Then we talked about vaults, big, structures that are built into the structure of the, building. And then we have safes, which are little smaller portable versions of that for, storing documents or, removable media in. Then we have equipment cooling concepts, and that's where you keep your equipment, safe and through environmental controls that prevents damage to them. You have the concept of the hot aisle and the cold aisle. You pull it up through the vents into a cooling unit, which pumps it out through the floor, usually into the systems again. So that's it for this chapter. If you have any questions, feel free to reach out, and I'll see you in the next video. Aloha.